Look at a couple things that we can do with our graphing calculator. The model I'm using is the TI-84 with CE, so the color edition. So on this one the graph's going to look nice. Some of you guys might have an older one. The functions will pretty much be the same, but your graph might just not look as pretty as on here. So if you haven't used a graphing calculator before, if you borrow one from me or from a friend, the front of it's going to look somewhat like what we see here on the left, and then on the right, the bigger part, that's what you'd see on your screen. So to get to where you need to go to be able to graph, you're going to go up and click on this y equals, and it'll take you to a screen that looks something like this, where you can put in the equation. So our equation is y equals something. So this first one that we're going to look at is y equals x squared minus 9 over x squared minus 4. There's a few different ways that we can enter that. Easiest and fastest is probably to do parentheses x squared minus 9 close parentheses divided by x squared minus 4 close those parentheses, and if you hit enter or down and move down to the next one, it should look something like that. Maybe you entered it nicely as a fraction. Some of you on the newer ones might have an option to do, where is that, math, go over to fraction and put it in, and it'll look like a nice fraction there on some of the newer models. But anyway, we've got our equation entered, so if we click graph, there we see a picture of our graph. So we see the 3 different sections. We see where we would have 2 different vertical asymptotes, and we see 2 X-intercepts, and then a horizontal asymptote as well. So I'm going to show you how we could use a graphing calculator to get the zeros of our numerator and of our denominator. So go back to the y equals, and on your next line, enter just the numerator. So enter x squared minus 9. And we're going to compare the graph of that to the whole function. So we've got that entered. Go back to your graph. And if you notice here, the x-intercepts of the numerator, of the graph of just the numerator, are exactly the same as the x-intercepts of the actual function, right? Based on the equation, you can probably tell that's positive and negative 3. But we could also use our calculator to spit out those exact values if we can't tell exactly what they are. So if you go back to your calculator and press second and then trace, so that the second actually gets us to this calc button, which I think is calculate. If we do second calc, we want to find the zeros, so go down to 0, and then I think pressing up and down will switch you back and forth between your 2 functions. So let's do the red one. So once we have the red one selected, it's asking for the left bound of our function. So I'm going to use that to estimate this right 0. So I'm going to go just to the left of that 0 and press enter. And now it asks for the right bound, so I'm going to move over to the right side of where we have that 0 and press enter again. So then it's asking, do you want to guess for the 0 between those 2 bounds? Enter again, and it tells me my 0 is at 3. Okay, so again, we could do that on the other one. Second calc, go to 0, and then we could use this to guess the other one. Up and down to, well, let's do this on the blue graph to find the 0 over here. So we go to the left side of that 0, enter. It asks for the right bound, so we move till we're on the right side of that 0 and press enter. It says, do you want to guess? So enter one more time, and it gives us that 0 at negative 3. So that tells us that the x-intercepts are at 3 and negative 3. So now we could do the same exact thing with our denominator. So go back to the y equals screen and enter the denominator as its own function. So x squared minus 4. Go back to our graph. And so now we see another function, the green one, and its x-intercepts, wherever that is 0, is where we're going to have the vertical asymptotes of our blue graph. Okay, so second calc in order to find the zeros of the green graph, so up and down until we've got our green one selected, y3. It's asking for the left bound, so I'm going to scroll to the left of that 0, enter. It's asking for the right bound, so move over to the right, enter again. Are you ready to guess? Yes. So enter one more time. Gives us a 0 at -2. So that's one of our vertical asymptotes, and we could do the same thing all over again. Second calc 0, switch so that we're on the green one. Move to the left of that 0, move to the right of that 0, enter one more time, and it gives us our x-intercept at 2, so that's our other vertical asymptote at -2 and 2. So we can do the same thing for all of these. If we go back to y equals, we're done with that first one. You've hopefully got the sketch of it. So if we clear all of those, we could enter our other one. I'm going to use the fraction, so make this one look nice. So this next one we have 10 over x squared plus 5. Enter. And I'm going to enter the two functions already. So x, oops, that's not right. X squared plus 5 for our denominator. And let's see what we can figure out from here. So enter, and let's go back to our graph. So the blue one is our actual function. That red one is our numerator, and that black equation, that black function, is the denominator. Since neither of those hit 0, since neither of them go through the x-axis, that tells us that our function has no vertical asymptotes, and that that function has no x-intercepts. So it's continuous all the way across. We can tell by the degrees that the horizontal asymptote is y equals 0. I would say plug in 0 into that equation. So if we go back, if we were to plug in 0, we would have 10 over 0 squared plus 5, so that's 10 over 5, which gives us 2. So at 0, we're at 2. So I'd plot that point, and then we would have to go through there to hit our horizontal asymptotes. And again, that's why I want you to take advantage of the graphing calculator and use those, because I don't expect you to know that that's exactly how this behaves just by looking at that equation. It takes quite a bit of practice to get used to being able to make assumptions as to how it's going to behave without seeing the graph with some help. Okay, so use your graphing calculator to help you out. The things that I do expect you to be able to do by hand are find the x-intercepts, the vertical asymptotes, and the horizontal asymptote. You should be able to do those things by hand, but then you can use the graphing calculator to help you get the image of that graph and get those things all drawn.